I would like to give the presentation on the emerging pollutants from two perspectives. One will be given from the perspective of the international network, and the second one will be the implication on the risk assessment of European river basins. In my normal civil life, I am director of Environmental Institute in Slovakia, but here I am in the position of the chairman of the Norman Association. I will explain some more about it later. First, I would like to explain the motivation, like why we come to emerging into the world of emerging substances. All of us know that there are many of them. I guess that there is more than 150,000 chemicals at the moment which are produced over 10 tons per year, and they can potentially enter the environment, but nobody is going to monitor 150,000 compounds. But then there is a legitimate question. So which ones, at which levels? We don't have any information on this because these compounds are usually not monitored. We see them in scientific studies or presentations like this all around. Everybody is coming with his favorite, and these favorites are usually differing among the countries, among the scientists. When the compounds are not monitored, they are not regulated. And because they are not regulated, they are not monitored. So this vicious cycle works all the time. And we are trying to find a way how to break it and how to take out the most important relevant pollutants out of this cycle and to deal with them. And we have heard in the previous presentation about REACH legislation. It's a very good tool to understand which compounds from those thousands are dangerous. And the second one is research. Always it's good to have some backup in legislation. In Europe, we are looking at some key packages. Number one is Water Framework Directive, where we can find emerging pollutants hidden in the ecological status assessment, and the emerging pollutants are called, according to Water Framework Directive, river basin specific pollutants, and each EU member state is obliged by this legislation to define these river basin specific pollutants, and if not, they are violating the law. So this is a good driving force to do something. One of the tools how to come into practice with this legislation is the Environmental Quality Standards Directive. There are some 41 plus substances which are regulated at the EU level, and this must be upgraded each 4 or 5 years, and this is an exercise which goes on all around Europe, and obviously only the top emerging substances which are everywhere and which are toxic will end up at this pan-European list of substances each water laboratory must do on a regular basis. Also, we are looking at the Groundwater Directive and Marine Strategy Framework Directive. They are also behind these two matrices, emerging substances in these two matrices. Drinking Water Directive as such is one of the oldest directives in Europe. It came into force in 1998. But it's a good one. It's protecting drinking water, but it's not really driving towards emerging substances. But there is a new thing, well, not new, I think it's since 2002. It's called water safety plans, and it's the approach by World Health Organization, WHO, that we don't look at the quality of the water in the tap. Water has to be opened, we take the tap, we analyze for a list of parameters, and if everything is below the limit, we say water is clean. It's not true, of course, because there might be many of the substances which are not regulated, and this approach of water safety plans is actually driving each water laboratory to do risk assessment in the whole chain from source of the water, river basin, up to the tap, and then to treat the risk at the point where it's really most effective. And very hot topics which are not covered by legislation at EU level at the moment is the soil and the sludge. We will hear a lot about it in the coming years. And very, very strongly we feel that the long-range transport of emerging pollutants is coming into the game. And today we are talking mostly about water, but we should not forget that there is indoor environment, which is one of the most terrible sources of emerging pollutants. Just considering that each baby is breathing about 200 milligrams of dust in a normal house, and babies are usually staying at home. And this dust from the vacuum cleaner, it's a terrible mess as regards emerging substances. So, going even further, we had an exercise at the EU level, finished just this year, that the so-called Water Framework Directive priority substances, those 41, were extended for 12 additional ones, where suddenly the names of the emerging substances we have seen in the presentations today are appearing, like diclofenac, PFOS, and so on. Environmental quality standards, it means the limit values are going down for many of the substances, and whole Europe is actually preparing now for the next upgrade of this legislation. And the way how to do it practically, it's so-called watch list. It's a part of this upgrade of the EQS directive. Joint Research Center of European Commission is organizing pan-European studies. Each country is nominating several sites, watch list sites, and they are coming there with some kind of list of emerging substances and measuring it all around Europe and finding out which of these substances are more important than the others and trying to find out which are the candidates to upgrade the list in the next 4 years. This is the slide I borrowed from Bernd Gaulik from Joint Research Center of European Commission. In 2010, there was a big exercise that all member states of European Union were supposed to provide data to DG Environment on whatever target substance, all emerging substances they had in their Excel files and drawers and reports and so on. And it was really impressive. I cannot show, but there's this number in the first block, 2000 to 2008, 14 million data, fantastic. 14 million data from around Europe was collected. Wow. Most of it for water. You see 96% of the data came for water, river water. Yeah? And then after first shock how great we are in the European Union, then the data analysis started. And you see benzene, very boring compound, everybody can do it. I think just by looking at the sample, and a lot of measurements, you see 26,000, and useful data almost 90%, great. But then cadmium. Cadmium is one of the tricky metals because it has got a little bit lower environmental quality standard than the other metals. And suddenly, from 100,000 measurements, we realized that only 1% of the data was actually measured by proper way and reaching these limits of quantification as we need. Well, scary. And then we come to not even so difficult, pentabrominated diphenyl ethers. They are here for many years, everybody is doing it nowadays. 536 measurements, 0 okay, yeah? And when we go to emerging substances, those thousands we are discussing here, this is the picture, 0. So, what to do about it? People who love emerging substances decided to break this kind of deadlock and started to think how to communicate between the politicians and scientists and to put forces together to move Europe a little bit forward. You probably, when you look at this picture, everybody can understand what's there. Like, we have a governmental institution there is somebody at Ministry of Environment dealing with the issue, but that person is so overloaded that he or she is not reading scientific publication. They are not even here to listen to the presentations, and whatever we are doing, actually, they never get the message. Then there is a big bunch of scientists who are producing thousands of publications on emerging substances and telling it's terribly important, but they don't know how to deliver it to the governmental institutions or the EU institutions. And there is a role for so-called interface institutions. There are many of them, but none of them are dealing with emerging substances. And this was the point where European Commission gave a project from 2005 to 2008 to establish, to fund Norman project, which in 2009 became a permanent network. It means members of the network, they are putting together their own money and exist together since 2009 as self-funded association. At the moment, this Norman network is having, it's more than 50, but I think latest number is 59 leading research institutes, universities, industries from all around Europe and Canada dealing specifically with emerging substances, everything from monitoring up to the removal. And the main goal is to exchange information among the countries. Everybody is doing a lot of interesting stuff, but we see a lot of duplication of efforts all around Europe, all around the world in the area of emerging substances. We would like to improve the data quality. It's a terrible mess. Data are not comparable. Everybody is using own formats. It's good only at presentations. Immediately as you try to go to real world and to take the data set, I don't know, from France and compare it with Norway, you are running into terrible, terrible difficulties. And we would like to promote synergies among research teams. This Norman is heading towards, having many activities, but heading towards one goal. It's the middle, this relevant pollutants. In the end, this is the only thing we want. How to get there? We are looking at the target screening data from all around Europe. We are also using non-target screening. I will spend some more time on this one. Effect-based analysis, it means bringing together chemistry and ecotoxicology. And all of this information goes into databases where we are storing data on monitoring, toxicity, and chemical properties data. And also, non-target screening goes in a separate database called mass bank. And then we apply prioritization mechanism on all of this data, and we find which are the top 5, top 10, top 100 using very specific approach. Just to aid this process, Norman Network has got several working groups on prioritization, bioassays, effect-directed analysis, engineered nanoparticles. It's a very vibrant life of the network. As we are sitting here, the guys from the passive sampling area, they had a meeting last week, moving the whole area a little bit forward and developing methodology or advice to DG Environment how to apply passive sampling in WFD compliant monitoring. 2 weeks ago, there was a kickoff meeting of a new working group on water reuse, and Norbert Kreutzinger, he's one of the founding members of this new working group of Norman Network. Effect-directed analysis, the bunch of people met just last week, Thursday, Friday, in Zurich, Switzerland, so things are really happening in a high speed. Databases, we have a so-called MPODAT database where occurrence and ecotoxicity data are stored on a list of emerging substances. I will show you later. And this Norman mass bank, it's the mass spectral information stored there in a very systematic way. And as regards the quality assurance, quality control issues highlighted by Professor Brauch earlier today, Norman network developed so-called method validation protocol, which is addressing the quality issues of all of this data, and it's becoming pretty official. It's now at the negotiation at CEN, and it will be the future CEN technical specification. Just the glimpse, like how we come to, like why we are so brave to talk about emerging substances in this context. There is a lot of work of many people around Europe behind this. So we are running permanently interlaboratory studies. We just pick up a bunch of interesting emerging substances, and we organize interlaboratory tests around Europe. In 2011, there was a very nice one, passive sampling exercise with about 30 laboratories from all around the world, including United States, Australia, taking samples from Brno in Czech Republic with their passive samplers, and we are trying to harmonize this field for analysis of emerging substances. Always we have international workshops. Whenever a new area pops up, we bring people together, there is a brainstorming, and after that there is some continuous work in the form of a working group. Just to give you, there were many, but just the last ones from 2012, you see micropollutants, metabolites and mixtures in drinking water and its sources in the Netherlands, wastewater reuse applications and contaminants of emerging concern in Cyprus. There was a very strong group on antibiotic resistance genes, which will join the working group I discussed before. Occurrence, fate and effects of emerging pollutants in the environment in the Netherlands in November last year, and so on. The practical work is not easy, but we have a lot of co-workers to help us to collect data on selected substances. You see 707 substances are at the moment on the list of Norman. We are just using expert know-how of all the members of the network, and each year we are updating this list. This year we will have almost 300 new compounds proposed by individual countries, and we are collecting basic data like KOW, KOC, solubility, fugacity data, for example. This is a good stuff. For each compound we know if we can find it more in water or in air or in the soil. Yeah? So it gives a very good indication where we should target the compound. PNEC, provisional no effect concentration, absolute basis. Without this we cannot move in the area of emerging substances. It's the threshold value. If the concentration is above PNEC, then everybody is dying in the river. Yeah? So it's this toxicity threshold, and we have to have it for each compound. And for emerging substances, we don't have it, of course, because they are unknown. Nobody has got enough money to measure ecotoxicological properties of all of these compounds in a way to derive PNEC. So we are using QSAR, quantitative structure activity relationship, with our colleagues at UFZ Leipzig to derive this toxic threshold for each of the compounds. And then we have a concentration in the environment, PNEC, and we can compare already, like is it above, below, and we can find out which compounds are more important than the others. At the moment there is more than 1 million data for 359 substances in the database, and also we are looking for the limits of quantification of available analytical techniques for these compounds, and trying to find out if these limits of quantification of best available techniques are good enough to match the PNEC values. And then, of course, we are looking for the PBT, persistency, bioaccumulation, toxicity properties, endocrine disrupting properties, which are known, yeah, but we collect it specifically for our emerging substances. And the latest hit is that we go for the use data. Until now, everybody is playing detective, like industries are happily pouring emerging substances into the water, and when somebody gets them, they put another methyl group on the molecule, and they have a new substance, and they happily produce further. Really boring game. So we are trying to collect the data now on the usage of the substances. It means how many tons of a substance is used, I don't know, in the shampoo or whatever, yeah? We have this database now only in Nordic countries because they are the most transparent. They just give it away. Everybody else is keeping it because this is such a secret. And I think analyzing these data sets, we will be able to predict what kind of substances we can expect in the environment in the years to come. And this is not a detective game anymore. Okay, so in the end, when we have all of this data, we are prioritizing them using the information we have. It means first we put them in the categories, and then within each category we say this is number 1, 2, 3, 4, 5. And we have categories where we know everything about the compounds, like category 1, we have enough monitoring data, we know everything about toxicity, and these compounds are ready to go to be regulated at EU level. Then we know about compounds which are, we have enough information, but they are not toxic, so we can stop measuring them, and some subcategories where we need more information about toxicity or collect more data and so on. And within each category we have our prioritization. All of this is published in numerous journals, and at the moment we were talking about the target substances. There is a big world of non-target screening where we are applying GCMS and LC high-resolution MS techniques to gather a lot of mass spectra from all around Europe and putting them into special database called Normal Mass Bank database. You can go there and it can help you to identify your compounds. And the vision is that we should have a common open access mass spectral database which help everybody to identify new emerging substances. And we are bringing together ecotoxicology and chemistry. Each sample we analyze first with a battery of harmonized bioassays. We want to harmonize it for whole Europe. And if it's toxic, then we analyze with mass spectrometry, target screening, and trying to find out that this compound is responsible for toxicity, and then we pay more attention to this compound. In the conclusions, I'm happy to be here at this audience, which is going a little bit beyond Europe. It's obvious that it's not possible to develop knowledge and methodologies at the national scale. Even countries like Germany, France, UK, they just cannot anymore. There is a need for international cooperation, and I hope that this will be one of the outcomes of this meeting, that there will be another groups in Europe which will contribute to this pan-European effort, and that we will find together the way how to prioritize the compounds the same way. So top 10 in Serbia, it's top 10 in United States or Canada or Germany. So this is kind of a final goal. And if somebody is interested to collaborate, I will be here for 2 days. Okay, thank you very much.